Hello, and welcome to this lesson on finding and understanding slope. So we are starting a new unit that is going to be talking about the equation of a line. And the first piece of that puzzle is being able to find the slope of a line and being able to use that slope to graph lines and past that. So that's kind of the first piece of the puzzle. That's what we're doing here in this lesson. We can see the central question says, how do I find the slope of a line and use it to graph lines? So we're going to be doing both of those things. We're going to find the slope of a line and we're going to graph a few lines today. Did you know that the slope of some common objects kind of make a big impact on your life? If the slope of your roof is too steep, the rain won't go in the gutter, it'll just kind of like fly right off. If it's really steep, it'll just kind of miss the gutter completely. If the slope is too shallow, if you have a very flat roof, you have to watch out and have extra supports because the snow can be so heavy that it can actually collapse your roof. If the slope of your yard is facing the wrong way, instead of water going kind of away from your house, like you'd want your house to be at the top of a hill, because then the water flows this way. But if your house is at the bottom of a hill, guess where the water's going to go? It's going to go right into your house. It's going to flood your basement. If a mountainside or a hill is too steep, it can cause landslides. Now, these are just various things talking about slope. They don't really kind of relate to the lesson as far as the slope of a line. But I'm just trying to get the idea of slope in your head and like what slope is. So the definition I have here is slope is how slanty a line is. It's how steep. I mean, this line here has a different slope than this line here and this line here. More steep, less steep, less steep. And we can find the slope of a line. We could actually get an actual number that shows the ratio of how far it goes up and how far it goes over. Basically, this ratio. We can find the slope of a line. So you can see this line goes up a lot more than it goes over. So that has a really steep line, where this third line only goes up a little bit, but it goes over a lot. So this is the formula we're going to use. Now, this formula is provided to you on the formula sheet. You may write down this formula everywhere. You may use this formula everywhere. You may use it on homeworks and notes and look it up and remember it. I recommend writing it down in nearly every single problem. So remember this formula. This is very, very, very important for the next about, all of Unit 4, Unit 5, Unit 6, Unit 7. So for the next 4 units, 4, 5, 6, 7, yep, this formula is going to be used in almost every single lesson, okay? And what this is trying to say is, if I undo actually a couple times, this top, so slope is m equals y2 minus y1 over x2 minus x1. It's telling us the change in the y, the change in the up and down, over change in x. A lot of times your teachers may have used the phrase rise over run. It's from one point to another. It's how far you go up or down, and then how far you go over. Okay, that's what the slope of a line is. Now, let's actually find it. So the first few problems here are just find the slope of the line that goes through these 2 points. So the first thing I like to do is I like to write down the formula. So m equals y2 minus y1 over x2 minus x1. Y is on top, x is on bottom. Now, this formula here, usually the very next step after you write down a formula is plugging in the known numbers into the formula. Well, we actually have these numbers right here, the y2, y1 things. It's these values here. We just got to know the right places to plug them into our formula. And the way we know that is, well, in an ordered pair, it always goes x, comma, y. X, comma, y. And since this is the first point, it's just the first on the page, I'm going to make this x1, y1. That's the x and the y value from the first point. This is the x and the y value from the second point. That's all the 1 and the 2 are doing for us. It's just a little label to tell us which is from point 1 and which is from point 2. So I'm now going to plug these 4 numbers where they belong in this formula. So y2, that's the y value from the second point, minus y1. So I did -4 minus +4 over x2 is the x value from the second point, minus x1. That is the x value from the first point. And notice I have 0 minus -2. I have the minus from the formula, but it's still a -2. So there's a few things you can do. One is just throw parentheses around it, because we don't like to have minuses and negatives touching. It gets very confusing, and you might accidentally slip and put them together and make it look like just one big minus sign. The other option is understanding that if you have minus a negative, 0 minus -2 is mathematically the same thing as 0 plus 2. Maybe you remember, or your teacher taught you, like when you are subtracting negatives, you keep the first one, you flip the sign of the number, and you change the value of the second one. So keep the first one, flip from minus to plus, and then change the sign of the second number. Or 0 minus -2. It's a +2. So whatever method you use, just make sure you actually do have both of them here, and then the next step when you do your math correctly, you get the right answer. And speaking of the next step in doing the math, now we are just going to simplify the top. -4 minus 4 is -8. Do the math across the bottom. 0 minus -2, we did that a second ago, is just plain old +2. And then the last step is to simplify our fraction. Our -8 over 2 can simplify to being -4 over 1. And I put a ghost over 1. It is there, and a lot of the times we need it. Slope is one of those things that we almost always want it as a fraction. Not 100% of the time, but most of the time. So if you have just -4, you're good, but understand that is a -4 over 1. And a lot of times we're going to use the over 1. All right, one more for me. M equals y2 minus y1 over x2 minus x1. That is the formula. I'm going to label and plug my numbers in. This is the x value from the first point, the y value from the first point. x2, y2. So x1, y1, x2, y2. I'm going to plug those values in. y2 minus y1, y2 minus y1 over x2 minus x1, x2 minus x1. And now, my math. Across the top, 1 minus 7 is -6. Across the bottom, -2 minus 3 is -5. If we try to type this in the calculator, fraction -6 over, down, I got -5. It gives us a mixed number. I don't really like the mixed number. Oopsie. I like the improper fraction, and we are going to want the improper fraction, which is just 6/5, which we could have saved ourselves a lot of time and button pushing if we knew that a negative divided by a negative, when you simplify, you get a positive answer. 6 over 5 itself, those numbers do not simplify. But a negative divided by a negative can simplify. These negatives can actually cancel out. They simplify, giving us just plain old positive 6/5. So those are the first two, and that's the whole process for finding slope using this given information. Now, I would like you to try two, please. So go ahead and pause the video, try these two on your own. When you're ready to continue, hit play, and we will go through it together. All right. M equals y2 minus y1 over x2 minus x1. Change color. Let's go purple. And this is x1, y1, x2, y2. So let's see, things we know, plugging in. y2 minus y1 over x2 minus x1. Check your numbers are in the right place in the formula. If they're in the wrong place, which is the number one mistake that people make in this problem, it's plugging these four numbers in these four spots. If you have them in a wrong spot, there's a good chance you're going to get a wrong answer. And think about, why did you plug it in the wrong spot? I mean, if y2 is in this kind of top left corner, y2 is -1. Plug a -1. Minus y1 is 8. X2 is -3 minus x1 is a +9. So if you made a mistake, check them out. Now we're going to do the math across the top. -1 minus 8 is -9. -3 minus 9 is -12. If you don't believe me, do the math in your calculator. But I'm not lying to you, at least not yet. -9 over -12 does simplify a couple different times. First off, our negatives are going to cancel. Negative divided by negative is positive. Guaranteed going to have a positive answer. Also, 9 over 12 does simplify. Simp equals 3/4. Positive 3/4 is our answer. Letter D. M equals y2 minus y1 over x2 minus x1. Change color, pink this time. x1, y1, x2, y2. Plugging our values in. y2 minus y1. I need the minus and the -2. Over x2 minus x1. I'm doing the math. 4 minus -2 is +6. 5 minus 2 on the bottom is a 3. And 6 over 3 simplifies to plain old 2 over 1. But 2. And that's done. So we found the slope of the line for both of these. And right now, these are just numbers. We don't really have a meaning behind what that number means yet. That's kind of part of what the rest of this lesson is supposed to help us. And again, we're going to be doing slope for the next 4 units. That's a long time. That's almost half of what we have to learn this year is dealing with slope and stuff. So now, let's actually start getting that idea of slope and getting some pictures put to it. So we're going to find the slope of the lines you see here. So we're also going to come up with a number, that same sort of fractiony number we were coming up with a second ago, but now we're going to do it from a line. So here's how this works. I'm looking at my line here, and I'm looking for where does my line go right through any of these little crisscrosses on the grid. They're called lattice points. Each of these little crisscrosses are lattice points. Well, I'm looking for where does my line go through any of them. Exactly. And I'm seeing there, 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 there. Do you notice how it follows a pattern? From one dot to the next, to the next, to the next, from each place on the line? Well, that pattern is the slope. It's how you get from one dot to the next to the next. That number, that pattern, is the slope. So here, For me to get from this dot here to the next dot, I'm going to go up 1 over 2. My slope of this line is the number 1 over 2. That is the rise over run that we were talking about earlier. And what do I mean by rise? I mean, how far from one point to the next do you go up or down? So we rose 1. We went up 1 block. How far did we run? And run, by the way, is always to the right. You never run to the left. Just like you read a piece of paper or you read a sentence from left to right, you read a line from left to right. So we ran 2 blocks to the right. So our slope is 1 over 2. Up 1 over 2. Now, I also like to use that phrase more than once. 1 over 2. 1, and then I went over 2. So I'm using the word over to mean 2 things in my brain. One is I'm moving over sideways, 1 over 2, but also 1 over 2. Okay. So this line has a slope of 1/2. That is the ratio of how far you went up to how far you went over. Now my letter B here is going down. Now my line is going through only 2 points on this graph. It's not going right through there. I can see the last points, the little crisscross. He's not going through there, and he's not going through any more. So from one dot to the next, remember, rise over run. Well, from one point to the next, I'm going to go down 1 over 1, 2, 3, 4, 5 blocks. Now, if I just put 1/5 like that, rise over run, that is not quite correct because my line is going down, not up. Just like if I had oopsie, my line's not good. I'm going to try to fix it. Give me just a second. There we go. Close enough. All right. So that new black line I just drew is going up 1 over 5. Well, that would also have a slope of 1 over 5. So we got to have some way to tell these two lines apart. One's going up and one's going down. The difference is a line that's going up has a positive slope, where a line that's going down, like the one in this actual problem, has a negative slope. This line has a slope of negative 1/5. It is going down 1 over 5, down 1 over 5, down 1 over 5. Okay, so negative is down, and it gives us a negative slope. I will do one more, and then I'm going to have you try one. So here's letter C. I'm looking for where my line goes right through the crisscrosses. 1, 2, 3 places. There is a pattern. From one dot to the next, I'm going to go down. Ooh, that was ugly. I'm going to go down and then over. Down and over. How far down and how far over, that pattern is my slope. So I'm going down 3 over 1. Down 3 over 1. And my slope is down 3 over 1. That is our rise, down 3. That is our run, over 1. So this line has a slope of negative 3, or negative 3 over 1. Technically, I guess we could put this over 1 as a ghost. We don't need it. It's not required, but it's good to have. But the slope of this line is negative 3. All right, so you've seen 3 examples now, so I want you to try one. Take this letter D, pause the video, try it on your own. When you're ready to continue, hit play, and then let's go through it together. All right, so hopefully you circled. Let's see. We've got that point there. I'm still in ghost mode. That one there. that one there, and that one there. So I've got 3 points again that follow this pattern. So down 1 over 1, 2, 3, 4. Over 4. Down 1, 1, 2, 3, 4. Good. The pattern continues. That pattern is the slope. Down 1 over 4. Down 1 over 4 is my slope. The slope is negative 1/4. That is the number of the slope. My rise means I'm going down 1. My run means I go over to the right 4 units. All right. Because this is such an important concept, I have 2 more for you to do, please. So if you could, please pause the video, try these 2 on your own. When you're ready to continue, hit play, and we'll do them together. All right, letter E. Boom, 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 boom. This is a very clear pattern. The pattern is I'm going to go up 1 block, over 1 block. Up 1, over 1, up 1, over 1, up 1, over 1, up 1, over 1. The slope is 1. Technically over 1, but the slope is 1. The rise is up 1 unit. The run is over 1 unit. Letter F. Boom, boom, boom. Up 1 over 3. Up 1 over 3. Up 1 over 3. The slope is 1/3. We went up 1, we went over 3. Okay, so now we know how to find slope from 2 points, and we have a little bit more understanding what that slope means. It is actually showing us how slanty or how steep the line is. The farther the number is away from 0, the steeper the line is. So a slope of -3 was fairly steep. Where a number like -1/4, it's still negative, but that number is much closer to 0. And look how kind of flat it is. If I had a slope of actual 0, a slope of 0 is a perfectly flat line. Where if I had a slope of, say, 1,000, my line would look almost straight up and down. There, we got technology. Let's try this. Y equals 1,000x. Now, let me see if I can get rid of some stuff here. So right now, there is a red line on the screen. It's a little hard to see. There we go. That red line is not actually straight up and down. It is going over very slowly. If I actually, there, see? It's actually moving slightly like this, in this direction. So it's kind of heading out here a little bit. Now, I'm going to zoom out a whole bunch of times. Now, I'm really far out, and we are at, well, not 0. It's not a straight up and down line. It's not like the x value is 0 here, but it's just really steep. Now, that was maybe too steep. It's hard to see that. How about 100x? Now, that also looks pretty steep. I mean, right here, you might say, oh, yeah, man, he's a straight up and down line. But as soon as I start moving up, you can see, oh, wait a second. It's not a perfectly straight up and down line. But this slope of 100 means I'm going to go up 100 before I finally go over 1 unit. That's up 100 over 1. Right there is the point 1, 100. Okay, so that's what the slope is doing. It's showing us how slanty, how steep our line is. So if you could take a second, go ahead and pause the video and think about what are the 2 methods for finding slope of a line that we've learned so far. The 2 methods that we've learned for finding slope so far are from 2 points, you use your slope formula, that m equals y2 minus y1 over x2 minus x1, and we find the slope using that. The second method we use for finding slope is from a picture, and we used our rise over run method and just looked at how our line is moving from one point to the next, the pattern of the line. Now we're going to kind of do the reverse of it. I'm going to give you a point. So as you see here in the graph, we have a point, and we are going to draw a line through that point with the slope they tell us. So this is going to help you further see what the slope of a line is. So from this one point right here, this dude, I'm going to move with this slope. Now that slope means I'm going to use that same pattern as before. The slope of 1/4 means I'm going to rise 1, and I'm going to run 4. Since my slope is positive, I'm going to go up 1. If this was a negative slope, I would be going down 1. So watch, I'm going to go up 1. Actually, let me do highlighter. Up 1 over 1, 2, 3, 4. Dot. Again, up 1 over 1, 2, 3, 4. Dot. Do you see how my points are making a straight line? That is the line that goes through that point with a slope of 1/4. And actually, I can even extend this way. I told you that run is always to the right. Well, what happens if you run out of space? How do I make my line go down here? Well, you kind of do the opposite of what the line says. Instead of going up 1 and to the right 4, you go down 1 and to the left 4. You'll see. Down 1, 1, 2, 3, 4, right here. So those 4 dots make a perfectly straight line. Now I'm going to use my straight line tool. You can use a ruler or whatever it is you're going to use. That is the line that goes to the point that they gave us, the original starting point, and has a slope of 1/4. Up 1 over 4. Up 1 over 4. Letter B. So from this point, we're going to go, see how it has a negative slope, -3 over 2? So we're going to go down 3 over 2. That's our rise over run. Our rise is downward because it's a negative slope. So I'm going to go down 3. 1, 2, 3 over 2. 1, 2. There is my first point. And I'm going to repeat that pattern. Down 3 over 2. Dot. And I don't think I can get any more dots on here. I can't go down 3 anymore or over 2. And even in reverse, up 1, 2, 3. I mean, I can have a ghost dot out here. It would be estimated here. Come on. There we go. And now when I draw my line, I try to make my line go from edge to edge. That's how you want your lines to go. That should extend the whole way across the graph. You should not have just a tiny little line like this. This is not what you want. That's not how lines work. Lines extend forever and ever and ever. So I'm extending from the whole way across the graph through each of my points. And that should be your goal as well. In fact, we should even add little arrowheads on the end of our line. I did not do it in the first one, so let's do it now. So now we show that our line goes on forever in that same direction, using that same pattern, which is called the slope. Okay, one more for me, and then there's one there for you. So I'm going to draw this line with a slope of 4. Now we've got a slight problem. My slope is not a fraction. Like if I'm looking at rise over run, I don't have that. I have one number. Is that the rise? Is that the run? What is it? Well, we've done this before. We can turn a whole number into a fraction by putting it over 1. In which case our rise is 4. So we're going to go up 4. It's positive. And our run is 1. we're going to go to the right 1 unit. Do you see a problem with that looking at our graph? I can't go up 4 from here. 1, 2, 3, 4. I mean, I'm out of space. Now, one thing you can do, you can always, extend it a little bit in your brain. So I'm going up 1, up 2, up 3, up 4 over 1. Just kind of get me in a little bit of an idea. It will be right about, come on, tool, right about there. So there is where my point will be. So my line's going like this. Now, I can also do the reverse of my rise of run. Instead of going up 4, right 1, I can go down 4, left 1. 1, 2, 3, 4, 1. Oh. Left 1. Boom. Notice how my 3 points are still in a nice straight line. I'm going to do it again. 1, 2, 3, 4 over 1. Boom. My line is a nice, pretty straight line. It extends from edge to edge of the graph. Or at least as far as I can make it. Yes, I could maybe extend this line a little bit, but it would be now less accurate. So I'm okay if you stop a little short, but it shouldn't just be like a little dude in the middle of the screen. It should extend most of the way across the graph all the time. All right, so now I've done 3. Here's one for you to try. So I want you to graph the line with a slope of -2. Go ahead and pause the video and try that one on your own right now. All right, so let's see what you did. Did you start by turning your slope into a fraction? Understanding that your rise is down 2. And your run is over 1. So from this point, you are going to go down 2 over 1 dot. And I would like to do it again, down 2 over 1. I mean, I could put a ghost dot out there, right about there. And in reverse, up 2 over 1, up 2 over 1 the wrong way, up 2 over 1 the wrong way. The whole way across, my line is still a straight line. There's no like weird zigzaggies happening anywhere. Oops, undo. I'm not trying to make it go through that bottom dot, because this dot was an estimation anyways. I really wanted to make sure it goes through these other ones that are actually right on the graph. And there's my line. My line has a negative slope because it's going down. From one dot to the next, I'm going down 2 over 1. Down 2 over 1. My slope is down 2 over 1. Okay, here is 2 more of this type. Go ahead and pause the video, try these 2 on your own, and when you're ready to continue, hit play, and we'll go through them together. All right, from here, up 1 over 1, 2, 3, 4, 5. That is the slope. Up 1 over 5. That's your rise over run. Up 1 over 1, 2, 3, 4, 5. I put a dot. I'm doing it again. Up 1, 1, 2, 3, 4, 5. That is my line. That is up 1 over 5. Up 1 over 5. My line looks like this. And hopefully yours does as well. Letter F. My line has a slope of -3/4. So already I know my line's going to look something ballpark like that. Like it's going down. I definitely know that because their slope is a negative. -3 over 4. Rise over run. Down 3 over 4. Now, where my dot starts, I cannot go down 3 over 4 because I don't have the space. I can only go down 2 and over 1. So instead of going down 3 over 4, I'm going to do the reverse of that. I'm going to go up 3 over 1, 2, 3, 4 the wrong way. Up 1, 2, 3, 1, 2, 3, 4 the wrong way. And now, well, I've got myself a line. I cannot extend it anymore because I can't go up 3 and over 4 more, so that's where my line's going to stop. I went as far as I could across the graph, though. So from each dot to the next, I could go down 1, 2, 3, over 1, 2, 3, 4. Down 3 over 4. Down 3 over 4 is my slope. All right, hopefully you had good success with that. That is how you graph the slope of a line. I believe this is the last skill for this lesson, and this is being able to find the slope of a line through points on a table. So if you look at this, letter A here, I have a table, and we would like to be able to find the slope of this line. This is a line. And how do we do that? Well, we're going to use that slope formula from back in the beginning. The m equals y2 minus y1 over x2 minus x1. That's the formula we're going to use. But we have a whole bunch of different points here we can use. Like this 2 comma negative 7. That's what this is. This is x comma y. 2 comma negative 7. This is a point. This is a point. This is a third point, and this is a fourth point. So if I was color coding this, we've got point 1, point 2, point 3, point, let's do green, point 4. Okay, now you're allowed to pick any 2 points you want when you're finding slope from a table. You can pick anything. So I typically try to pick points that I think will make my math easy. I like to avoid negative numbers, and I like to avoid ugly decimals and fractions if I can. Now looking at these points, we're not going to avoid negatives because all of my y values are negative. So it really doesn't matter what you pick. So I'm going to pick these 2 points. So that would make this my x and y value, and I'm going to call him point 1. That's the x and y value from point 1, and then that would be my x2 and my y2, the x and y value from the second point. And I'm just going to take these 4 numbers, plug them in here, and find my slope. Check this out. y2 minus y1 over x2 minus x1. Math across the top. Negative 8 minus negative 7 is negative 1. Don't believe me. Negative 8 minus negative 7 is negative 1. Over 4 minus 2 is 2. My fraction of negative 1/2 does not simplify, so this line has a slope of negative 1/2. Now I said you could have picked any 2 points you want. If I pick these bottom 2 points, I'm going to get the same slope. I'm going to use x1, y1, x2, y2. You do not have to do this twice. I'm showing you that you could have done this twice and ended up with the same answer. So y2 minus y1 over x2 minus x1 gives me negative 1 over 2. We got the same slope. So pick any points you want that makes you happy. Like letter B here. Lots of negatives. Lots and lots of negatives. But also look at your table. Now, x's are here across the top, and y's are across the bottom. So I would pick these 2 points because the numbers are smaller. I don't want to deal with negative 38 if I could deal with a negative 2. I like to pick small numbers. The math's easier to do in my head. M equals y2 minus y1. over x2 minus x1. Make sure you label properly. If I'm using this point and this point, I've got x value from my first point, the y value from my first point, x value from the second point, and the y value from the second point, which gives me y2 minus y1 over x2 minus x1. Doing the math, -2 minus -8 is a +6, and 0 minus -1 is a +1, which gives us a slope of 6 over 1. I mean, technically just 6, but understanding that it is over 1. Okay, so from a table, you pick any 2 points you want. Make sure you have them labeled properly, like is your table going up and down? Is it going left and right? Make sure you have your correct x values. These are both x's. Y values, these are both y's. And then plug them into the same slope formula we have been using, and you will be golden. All right, if you could please try these two right now. Pause the video, try them on your own. When you're ready to continue, hit play, and we will go through it together. All right. Well, looking at this table for letter C, I would use these 2 points because it's got the smallest numbers. So, formula. M equals y2 minus y1 over x2 minus x1. This is the x and y value of the first point. This is the x and the y value of the second point. I'm going to plug those numbers into my formula, giving me y2 minus y1. I'm being very careful when I'm looking back to make sure I'm actually plugging the right numbers in here. Like I was saying y2, and I was looking, okay, that's a 17, minus y1, okay, that's a 14. That's very, very strategic and careful and cautious as you're plugging these numbers in. Because again, getting these 4 numbers in is the #1 mistake that students make in these problems. From here on, the rest of the problem is easy. Anybody can type this into their calculator and get it right. But getting numbers plugged in properly is the challenging part. 17 minus 4 is 3 across the top. Down the bottom, 9 minus 6 is 3 across the bottom, which simplifies. 3 over 3 simplifies to 1 over 1. But 1 is our answer. This line has a slope of 1. Letter D. I guarantee I'm going to be using this point because both numbers are positive. And you know what? I'm also going to use this one. We haven't done any time where we've had 2 different points that aren't side by side, and they don't have to be. x1, y1, x2, y2. I said you're allowed to pick any 2 points you want. So, I mean, I've got 1, 2, 3, 4 sets of points, so I'm going to pick the ones I want. Formula. I actually have it right here, so I'm not going to write it down again because I have him right here. He's visible to me. There we go. So y2 minus y1 over x2 minus x1. Make sure you had your numbers plugged in the right place. That's the #1 mistake. And now we math. 2 minus -6. I'm sorry. 2 minus -4 is 6. My brain was working, or my mouth was working faster than my brain. And 4 minus 0 is, well, just 4. That fraction does simplify to 3 over 2. That line has a slope of 3 over 2. Which means if I had to graph this, I would go up 3 over 2, up 3 over 2, up 3 over 2. That's what this says. Summary. We're done. Describe in your own words how to find the slope from any of the methods we learned in this lesson. This does not need to be a question mark. How about an exclamation point? Excited. Describe in your own words how to find the slope using any of the methods we learned. So we learned 3 different ways of finding slope. We found slope from 2 points. We found slope from a graph. We even actually graphed a couple lines. And then we found slope from a table. So pause the video. Describe at least one of those right now in your own words. And then hit play, and then we'll go through them together. All right, so I'm actually going to scroll up here. Instead of writing out words, I'm going to show. So, to find the slope from 2 points, we used our slope formula. This is the slope formula. We labeled our points x1, y1, x2, y2, meaning the x and the y value of the first point, the x and the y value of the second point. We plugged our numbers into our formula, and then we just did the math. And that was our slope. Now we know what this actually means. It means this line would look something like this, where from one point to another, it's going to go down 4 over 1. We didn't know that originally, but now we do. The second type of slope we found is from a graph. We saw that that represents the pattern from one point to the next, to the next, to the next on the line. So if you went up 1 over 2, your slope was 1 over 2. If you went down 1 and then over 5, your slope was a negative 1 over 5. Positive slopes go up, negative slopes go down. And the last thing we learned was how to find slope from a table. And we found that you can use any 2 points you want. You get the same answer, but we just use that same slope formula. So you have more choices, which a lot of times is harder because we like not having choices. We like things just being given to us. But you can pick any 2 points you want and do the math using the same slope formula, and you get your answer. So that's what we did. That's how you would have described at least one of those methods. Okay, thank you so much for watching this video on slope, and until next time, toodles.